The whole reason we're all here, we're all doing this together, is for decarbonisation, and shipping accounts for up to 3% of global CO2 emissions, equivalent to a country like Germany or Japan. It's companies like ours that are really moving the needle in the decarbonisation movement to reduce the emissions of these ships and really make this planet a little greener. The idea for this Airwing technology stems from aeronautical applications. I had done a lot of research previously on suction and blowing systems for aircraft wings for high lift applications, and we've adapted it to be used on a ship for a wind propulsion system that's never been done before. When you put one of these devices on a ship, they can be much smaller and have much less impact on the operation of the vessel in comparison to other technologies which are larger. I realised there was a gap in the market for a new type of technology, one that was able to produce a lot of thrust but from a much smaller and much more compact size unit. Airwing effectively uses both suction and blowing to manipulate the flow around the device, so that's where the inspiration came for really starting this product and developing something that was completely new. MMS have been really instrumental in actually getting this Airwing assembled. Without them, we couldn't have put it together and put it on the ship. Tony's the guy in charge around here. He's the guy that makes things happen and gets things moving.
The engineers have enjoyed this project basically because it has been different for them and challenging, and they've risen to the challenge. So it's quite an exciting project for us because it's one of its very first in the country, I believe.
A few weeks back we had the Maritime Minister come to visit the site. He really, he really was impressed with everything that had happened.
I didn't realise that using such innovative technology that's often used in aircraft manufacture could be transposed to shipping, but with the brilliant engineers here at MMS, they are doing that with the innovative design. We hope to see it up and running and trials literally within weeks. We've pumped far too many hydrocarbons into our atmospheres over the last 40 years. We are suffering the impacts of climate change, and we're seeing the flooding that we've had across the nation increasing, even in my own constituency just last week.
Martin and Kushru have been really instrumental in this project. Martin is product director, so he's in charge of all of the product, making sure it gets to the site, is manufactured, and Kushru is the COO. His job is to make sure the wing is assembled properly, installed. He's the real point of contact for the client. And a lot of them are waiting to see the results of this first installation. They're specifically interested in reliability, what the build quality was like, and basically just getting a feel for the technology, seeing it up close, being there in person. There's nothing better to understand.
Hapag-Lloyd is a container shipping company, the 5th largest container liner in the world. We have a decarbonization goal of reducing the CO2 emissions until 2030 by minus 30% for our entire fleet. And wind assisted is one of the technologies which we are looking into, helping us to achieving that target.
We are really lucky to have a great bunch of investors that are very supportive, both financially but also emotionally. We've got VC backers, but also a lot of angels, some family. So without all of those investors, without their input, we wouldn't have been able to do this project. So they're all very excited about this, very excited to see where it goes. Carisbrooke are going to be really interested in the performance of the wing, understanding how much fuel it saves, how much carbon emissions it reduces. They've been a real key partner of ours from the client side. Without them, it would have taken a lot longer to get a device onto a ship. The sea trials will happen initially out in the North Sea, so we're going to first test the operation of the wing and also some of the performance. And then the ship's going to be going onto its normal route to Bilbao and then off to Canada, where we're really going to test the wing in its natural environment.
We have to transition from old fossil fuels to become a clean energy superpower, and we're going to need the finest engineers, the finest ports and the finest shipping companies to help us do that as a nation. Government can't do that.
The future for GT Wings really is scale. There's a lot of ships out there, there's a big fleet that needs to decarbonise, and we're really there. We want to be the front runners, really driving decarbonisation in the shipping space.